So hello students, in this lecture I have delivered about the application of the op-amp as a differentiator. So in this case when we use the op-amp as a differentiator, so in this case we have changes the values of the positions of the capacitors and resistance when we use is as an integrator. So in this case we have reversed the positions across the integrator where we use the changes the positions of the capacitor and resistances. So we have used the resistance as a feedback element between the output and the input, and we have used the capacitor with the source voltage Vs here. So in this case we have used the capacitor with source voltage as the inverting terminal of the op amp, and when we use the second terminal, that is our non-inverting terminal. So in this case we have used this non-inverting terminal, so it is terminal we have used as a ground terminal. We have grounded, so non-inverting terminal is grounded. So according to this, value of the V2 is equal to 0. So at the phenomena of the virtual ground of the op amp, so automatically we have here put the node, that is V1, which is automatically grounded by the virtual ground. So in this case, due to the high input impedance of the op amp, so current in the op amp, that is IB1, is nearly equal to 0. So in this case the total current is the sum, feedback current is the sum of Is plus Ib1. So Ib1 is equal to Is plus If. So here when we calculate and put the values, Ib1 is equal to 0, so Is is equal to If. Basically source current is the feedback current which is generated in the flowing in the across the resistance Rf, and we have calculated the output according to it. So in this case we have used this KCL at node 1 and 2, and we equated the different source and feedback currents, then by which we have calculated the output in terms of differentiating way. So in this case we have first calculate the current values. First current, that is our Is where we use the element, that is our capacitor. So in this case Is is equal to C into D, Vs differential voltage divided by time. So in this case Is is equal to C D Vs minus V1 divided by dt. So in this case our V1 voltage is 0 due to the virtual ground property. So in this case I have calculated I is equal to C dVs by dt. So in the same way we have calculated the feedback current, that is the difference of the two voltages, input and output terminals, that is V1 minus V0 divided by resistance Rf. So in this case when V1 is equal to 0 due to virtual ground, so in this case If is equal to minus V0 by Rf. So these two currents we have calculated, and current Ib1 is 0 due to the high input impedance of the op amp. So in this case we have applied the KCL at node 1. So in this case both the currents are equal, Is is equal to If, and we can put these values, two values in the same way in this equation. So in this case we have calculated C dVs by dt is equal to minus V0 by Rf. So in this case when we calculate this value, V0 is equal to minus Rf C dVs by dV, means output voltage is basically a differentiation of the input voltage and is multiplied by a factor of minus Rf into C. Means we have generated the output, that is basically the factor multiplied by a factor, that is basically the Rf, that is the feedback resistance which you have used here, and the capacitor value. So in this case we have also generated the negative sign, which is denote the phase reversal in the output. So it is the output of the differentiation circuit. So basically we have used here the square wave in the output. So in this case we have generated the output in terms of pulses in the output waveform. So these are the output of, according to when we provide the input square wave and generated the pulses in the output. So when we use the another application, that is our precision rectifiers. So basically the rectifiers which I have earlier told that when we use the diode as a rectified element between the input source and load. So in this case when we use the ideal diode, then we use as ideal, means we have used only the shorts and open circuit in terms of diode. But when you use the practical diode between the input source and load, then according to that when we use the silicon and germanium diodes, then it have some cut-in voltage. In case of silicon that is 0.7 volt, and in case of germanium that is 0.3 volt. Suppose when we applied the input below this 0.7 volt, then according to that, diode is work as an open circuit, and we have not generated the output. And when we are giving the input voltage more than this 0.7 volt, then diode is shorted and we have provided the output in terms of input. So when we use the low voltages to which we have want to rectify, so in this case we have used the diode as a precision rectifier. So in this case for we use the low voltages like a millivolts in the output and generate the output according to this, we have used the precision rectifier circuit. In this case we have used the op-amp with a series element as a diode in the and some different input or non-inverting configurations in a voltage follower way. So that is the example of positive precision half wave rectifier. Means half wave means we have generated the half wave with respect to input voltage, and we use here the inverting terminal of op-amp, and which is we have introduced with respect to output voltage and connect with the output voltage V0, and the output of op-amp and the load across RL, we have inserted a voltage inserted a diode between them, and we have introduced a voltage at non-inverting terminal, that is V2 with respect to ground. So in this case positive half wave precision rectifiers, we have only generated the positive wave in a rectified manner in the output. In the that depends on the position of the diode with respect to input terminal, that is positive or negative, and it is off condition or is a non condition with respect to input source, where which we have generated the output with respect to input. So in this case according to waveforms, we have generated according to when the diode is on and is off. When diode is on, we have generated the output in terms of between the 0 and pi, and it is off that, and we have vanishes the output between the pi and 2 pi. So in this case we have generated the positive wave. So in this case positive half wave precision rectifier, when we apply the voltage source Vs at the non-inverting terminal, so in this case when we provide the voltage source and non-inverting terminal, in this case, and when we generate the output, that is basically the positive. So when we this output is positive, Vs is greater than 0, according to this, diode is in forward bias, it is shorted, and we have take the output in terms of positive way. But so in this way we have generated the output, that is basically that is difference between the V0 minus 0.7 and difference of this particular voltage. So V0 is equal to Vs plus 0.7, and the diode which have already have voltage of 0.7 volt, so in this case 0.7 is cancelled, and we have generated total Vs in the output when we have applied the positive cycle. But when we applied the negative cycle in the voltage source, means Vs is less than 0, so in this case condition the output which is negative, which is reverse biases the diode. So the diode is in open circuit, and we have doesn't take any output, and V naught is equal to 0, so vanishes the output due to the off of this diode between the pi and 2 pi. So in this case we have used this positive precision rectifier. So when we use the another in terms of negative precision rectifier also, that depends on the position of diode. At the previous way, here we use the circuit, we have used the change of this position according to input op-amp. So in this case same things are apply here and voltage apply at the non-inverting terminal, and we only change the position of the diode with respect to our previous configuration. So in this case when we applied when we use the diode as a precision rectifier, in this case due to negative precision half wave rectifier, we have generated only the negative output and vanishes the positive way. So in this case when we use the voltage Vs is greater than 0, in this case output of the op-amp is positive, but this positive value, it is reverse biases the output, so output is an off circuit, and we have generated the output is equal to 0. So in this case when we applied the positive half cycle, Vs is greater than 0, then we have doesn't take any output, and between the 0 pi, that is 0. And when we applied the negative half cycle, means when Vs is less than equal to Vs is less than 0, so in this case output of the diode which is basically the positive, output of the diode, that is basically the negative, and this negative voltage forward biases the diode, so diode is a short circuit, and we have generated the output in terms of V0. So V0 is equal to minus, that is equal to we have generated between the pi and 2 pi in terms of minus Vs. So vanishes the output in positive half cycle, and we have get the output in between the pi and 2 pi in terms of negative Vs. So this is the example of positive and negative precision half wave rectifiers. So thank you.